Okay, these are the solutions to Summer 2023 Ccea Mathematics A21 unit. This is a pure maths. Okay, first thing, it says to give answers correct to 3 significant figures unless told otherwise. Okay, question 1, nice easy radians question to get us started. It says calculate the area of the minor sector. So the sector is a whole pizza slice, and the area of the sector area is given by a half r squared theta, and that's where theta is in radians, which it is. So half times r squared, so 7.2 squared times your 1.2, which works out to be 31.1 centimeters squared to 3 sig figs. Now jump straight to the rounded version because we don't need this for the latter parts of the question. Next one, find the length of the chord AB. So for the chord AB, just to show us in, the chord AB would be this bit up here, so that wee chord. So I'll just draw that diagram again down here just so it makes it easier for us to see. Oh, changed to red for some reason. So we've got this, we knew this was 1.2 radians, this was 7.2, and I'm going to call the length of my chord 2x. Now I'm going to do that because I'm going to divide that into, make that into a right angle triangle, which divides that, bisects the angle. So it now becomes 1.6 radians, that's still 7.2. And instead of 2x, that bit is just x. So relative to my 0.6 radians, that's my opposite, and this is my hypotenuse. So it's basic sine, remember sine theta is equal to opposite over hypotenuse. So sine of 0.6 is equal to x over 7.2. Wee bit of rearranging, then 7.2 times sine of 0.6 is equal to x. Now that means 2x, a chord, what we're looking for, 2x is equal to 2 times 7.2 times sine of 0.6. And I've done that out, and I've done a few more decimal places here because I'm going to use this in the next part of the question. So that's what it is, and then to 3 sig figs, give your answer to 3 sig figs, 8.31 to 3 sig figs, and that's centimeters it should be. Okay, next part says, hence find the perimeter of the minor segment. Right, let's look at our diagram again. Our diagram was like this. We've now worked out what AB is. AB was our 2x, remember? And the minor segment, the segment is this wee bit, like if you imagine the top of an ice cream cone, that's what it is. So you've got the 2x, and this thing is what's called the arc length. I always call it L. So the perimeter of the segment then is going to be equal to our 2x, which we've just worked out, plus L. Now L, if it's in radians, is r theta. What was r theta? It was 1.2, and the r was 7.2. 7.2. So r theta is going to be 7.2 times 1.2, which works out as 8.64. Your perimeter then is in the 8.64 plus your 2x. 2x we worked out as 8.1305. And work that out, that's 16.77085. And then your perimeter to 3 sig figs again is 16.8 centimeters, and that is to 3 sig figs. So nice easy question. Next one says solve the following. Nice easy one again. You've got an inequality, not even a quadratic inequality. So do 4x plus 1 is greater than 5, or 4x minus 1 is less than, and change the sign to minus 5. Let's tidy this up. That's 4x is greater than 6, which means x is greater than 6 over 4, which is 1.5. Or over here, bring that minus 1 across, you'll have minus 1 across becomes plus 1, so minus 5 plus 1 is minus 4, and x is less than minus 1. So x is less than minus 1, or x is greater than 1.5. Next one, binomial. Find the values of p and q. The way I do these, I think that 1 plus squiggle, so that's anything, to the power of n is 1 plus n times the squiggle plus n times n minus 1 times whatever that thing is squared divided by 2 factorial, and you'd go on from there. But we don't need to go on because it only goes up to the quadratic term, so you're wasting your time writing it anymore. Okay, so 1 plus, and it was, it was qx, was it? Qx to the power of p. So then that's 1 plus, and the n is equivalent to p, squiggle is equivalent to qx, and then p, and p minus 1, and then qx squared. And when I was doing this out, I made a mistake in this. When you're doing that out, just take care. So that's going to be 1 plus pqx, and then do this out. I just did the p times the p plus q is going to be p squared minus p. That's all over 2. And this is where I made the mistake. Square the q and square the x. So that thing is multiplying q squared times x squared. Okay, and go on from there. Right, we want to then equate the coefficients. So we want to equate the coefficients of x. So that means this thing here, where's my coefficient of x? This thing must equal minus 6. So PQ equals minus 6. Therefore, Q, I know from experience, I know we'll be doing this, Q then equals minus 6 over P. Also, we want to equate the coefficients of x squared. So in blue, you'll do them. So in x squared, coefficient of x squared, we have plus 24 is going to be equal to this thing. So not as far as the x squared, all over 2. So it's a mess, but let's look at it and see. So what have we got? We've got p squared minus p, all times q squared, all divided by 2 is equal to 24. That's tied up a wee bit. That's p squared minus p times q squared is equal to 48. And then we're going to sub in the fact that q is equal to minus 6 over p. So it now becomes p squared minus p times minus 6 over p, and that's squared, is equal to 48. Let's write that out again. That's going to be p squared minus p times, and that's going to be 36 over p squared is equal to 48. And I'm going to do two things here in one go. So we have p squared minus p upon the 36 over p squared is equal to 48. I'm going to multiply across by the p squared. So I'll have a p squared over here, and I'm also going to divide across by the 36. Have I done that at all? Haven't done that. That's nonsense. I'll just leave the 48 here where it is and multiply through by the 36. Apologies. So I should have had 36p squared minus 36p. Then bring it all to one side, put it equal to 0. I'm going to have 0 is equal to 12p squared plus 36p, and then pull 12p outside. So 12p comes outside, leaving you p plus 3, which means p is equal to 0, which isn't going to be possible for us, or p plus 3 is equal to 0, which means p is equal to minus 3. So just say when p is equal to minus 3, your q is equal to minus 6 over minus 3, so q is equal to 2. So your answer, p equals minus 3, q equals 2. Next one says, state the range of values for x for which binomial expansion is valid. Your expansion now is 1 plus 2x to the power of minus 3. And what I teach people is if you have it in the form 1 plus squiggle to the power of n, it's valid for modulus of squiggle is less than 1. Okay, so this in this case, this is valid for modulus of 2x is less than 1. Divide across by the 2, you'll have modulus of x is less than a half. It's when it's valid. Okay, next question, trapezium rule. Right, it says find the area enclosed by this thing using the trapezium rule. So, and it says, trapezium rule with 4 strips. So just do this out. I would just mark on where the things would be. Then it just makes it easier for you to see. Then your n values are 0, 0.25, 0.5, 0.75, and so on. And then the way I do the trapezium rule, I'll just have my x. So my x values were 0, 0.25, 0.5, 0.75, and 1. And then I do the n's, and then I do the rest. And also my h is the width of the strips, which is 0.25, because I was 0.25 between each of those. That's all that is. And then we just work those out. Okay, how you work out these values. So you put 0, to get this one here, you're putting 0 into this thing. So 0 squared, square root of times 0 cubed plus 1. So that's what you're doing. So that one clearly just works out as 0. And the rest of them then, so to get this one 0.25, you put 0.25 in. So 0.25 squared times the square root of 0.25 cubed, then plus 1. And that worked out as 0.062986. The next one worked out perfectly as 3 root 2. Sorry, I'll zoom in on this. 3 root 2 over 16. The next one was 0.670739. The next one worked out perfectly as root of 2. So add up that column, you get root 2. Add up this column, you get 0.99889. And then your area is h over 2 times the ends plus 2 times the rest. And you just fire that in. So that's 0.25 over 2. The ends was root 2. Then 2 times 0.99889. And fire that in. And what I got when I fired that in was 0.426, and again that was the 3 sig figs. Okay, says next one says find the volume of a solid. Now your formula for finding the volume of revolutions, so it says this thing is rotated through 2 pi, so it's pi times the integral from a to b, they're the x values of y squared dx. So in this case, that's going to be pi. The integral was between 0 and 1. So 0 and 1. And if you square your y, let's just write down what your y was. It was x squared times the square root of x cubed plus 1. If you square that, y squared is going to be equal to x to the 4 times x cubed plus 1. And then that would multiply out to be x to the 7 plus x to the 4. So that's where you're integrating x to the 7 plus x to the 4 dx. So if you integrate that, square bracket, it's going to be x to the 8 over 8 plus x to the 5 over 5, and that's between 1 and 0. So fire that in. Right. The first bracket, you only have to worry about. The second one's got a 0 in it, which is great. Happy days. The first one's just going to be 1 over 8 plus 1 over 5, which works out perfectly to be 13 pi over 40. It doesn't say to find the exact value, so we'll just work it out as 1.02. And that's going to be units cubed, and that was the 3 sig figs. Okay, next one, the function of sine to the minus 1. I have never learned these, and I never will, but I know how to get them. So how you get your sine graph, your inverse sine graph, is you know what your sine graph looks like. It's a 1-to-1 between, and that would have been between what? Pi over 2 and minus pi over 2. And that's what it goes. It goes from 1 to minus 1. Now, if you reflect that, if you imagine you reflect that in this line, what it will then become will be this. Okay, so that's the way your graph is going to look. So the general shape of your graph, sort of make it like a square axis, if you know what I mean. Those 4 things are equal in length. And then it goes from here. Now that's your sine to the minus 1 graph, and that is pi over 2 minus pi over 2, and that's minus 1, and that's plus 1. So notice these axes things have switched around. So what was on the y-axis now goes on to the x-axis, and vice versa. So that's what you've got for your inverse of sine. State clearly the domain. So the domain is just the x value, so it's really easy. Once you've done the curve, you're getting marks for writing the same thing. The domain is minus 1 is less than or equal to x is less than or equal to 1. Your range then is minus pi over 2 is less than or equal to sine to the minus 1 of x is less than or equal to plus pi over 2. And that is it. Okay, state the 2 successive transformation which maps your graph of sine to the minus 1 onto this thing. So you're getting 3 marks here. I'm guessing your 3 marks were saying for the 2 transformations and getting them in the correct order for the 3rd mark. So the first thing you're doing is you're multiplying this by 2. So that means that's a stretch scale factor equal to 2 parallel to the y-axis. So that's a stretch vertically scale factor 2 basically. And then you're adding 3, which again is then sorry, and then it'll say, then translate it 3 units up. Okay, so you've got to, in some way, say that the order that you're doing that one first, and then you're doing the other ones. Order matters. Okay, next one is a partial fractions question. Lovely. We're going to say that's 25x over x minus 2, x plus 3 squared is identically equal to a over x minus 2 plus b over x plus 3 plus c over x plus 3, and this one is squared. If you multiply it across, you'd get 25x identically equal to a times x plus 3 squared plus b times x minus 2 times x plus 3, and then plus c times x minus 2. Now, sub in values in. So when x equals minus 3, you're going to get minus 75 on the left-hand side, and then this first bracket would become 0, second set of brackets would become 0, and you're going to have just c times minus 5, or minus 5c. Wee bit of working out gives you c is equal to positive 15. Put that in a wee box when you find it. This makes it easier for you going forward to find your work. Next one, put x equals 2 in, and then you will have 25 times 2 is 50. The first bracket then will become 5 squared times a, so that means 50 is equal to 25a, and again a wee bit of working out gives you a is equal to 2. And the last thing, you could put in any value and then just solve the equation to find it, but I like to just do a mixture of subbing and equating. So I'm going to equate my coefficient of x squared, sorry. So on my left hand side I have no x squareds. On my right hand side, if I multiplied this out, I'd have x, somewhere along the x squared term, I'll have x squared times a, so I'll have a. If I multiplied this out, I'd have x squared times b, so I'd have another b one. And if I multiplied this out, I wouldn't have any x squared terms at all. So that's all you have, and you knew your value of a. A was 2, so 2 plus b, wee bit of working out, b is equal to minus 2, put that in a wee box as well. So you've got your a, b and your c, so your answer, partial fractions, and it's 2 over x minus 2. What was my b? It was minus, wasn't it? Minus 2 over x plus 3, and then plus, c was 15, 15 over x plus 3 squared. And no doubt we'll have to do something with this in the next part of the question. And of course we do. We have to integrate that thing. So what we're doing then, we're integrating this thing. So it was from 0 to 1. And it was, what was it, 2 over x minus 2. Minus 2 over x plus 3. And then plus 15. And I'm just writing this one. Instead of writing it as 15 over x plus 3, I'm going to write it as 15 times x plus 3. That's to the minus 2. And then we can integrate that. Okay, the first two are really easy to integrate. I'm going to look, I'll call that my I, that's my integral. I'll come back to that in a wee second. I'm going to integrate this one by inspection. So what I mean by that is I'm going to raise the power by 1 and differentiate and see what I get. So I'm going to differentiate just 15 x plus 3 to the minus 1 and see what I get if I differentiate this thing. So differentiate that, you're just going to get difference with respect to the power, you'll get a minus and 15 x plus 3 to the to the minus 2. So it isn't quite what I wanted. So therefore, if I differentiate minus 15 x plus 3 to the minus 1 with respect to x, I'll get what I want. I'll get positive 15 x plus 3 to the minus 2. So that means I differentiate this thing and I get this. That means if I go the other way around, if I integrate the 15x plus 3 to the minus 2, I'll get the minus 15x plus 3 to the minus 1. Okay, so my I equals, I'll write in that wee bit that I've just done, I've worked that out, that's going to be minus 15x plus 3 to the minus 1. Okay, so that's that bit I've done. The other bit's then integrating this thing here. If I integrate this, I'm just going to get ln modulus of x minus 2, and they're testing this in this question. Integrate the next bit, I'm going to, sorry, I should have 2 there in front of that. Integrate the next bit, it's going to be 2 times ln of modulus x plus 3. And then we'll just go ahead with that. So just take care on this. Very, very easy to make a mistake. And if I've made a mistake, I apologize. Here, so first bracket, so this is just firing in the the x equals 1. So you're going to have 2 times ln of modulus of 1 minus 2 is minus 1. Modulus of that will be sorting that out in a wee second. Minus 2 times ln of modulus, and that will be 4. And then that's going to be minus 15 over 4. That's my first square bracket. My second bracket, so putting in the 0, that's going to be 2 ln of modulus of minus 2, minus 2 ln of 3, and then minus 15 over 3, sorry for squeezing that in. And then, let's see if I can just tidy this up a wee bit. Right, that's the same as 2 ln of 1, making modulus n, minus 2 ln of 4, and that's just going to be minus 15 over 4. There's nothing I can do with that. Then do these ones, minus 2 ln of 2, that's going to be, then that's going to be plus 2 ln of 3, and then 15 over 3 is minus 5, so that's what you've got. Let me fix that, that's a mess. Okay, never do an exam what I've just done. You should never write outside that box. That's just so that we can see it. Okay, so that's what you've got. Tidy that up, and if I've done this correctly, when I tidied that up, so I'm tidying up this line here. First of all, ln of 1 is 0, so that just disappears, so that just goes to 0. Then minus 2 ln 4, minus 2 ln 2, plus 2 ln 3, and then minus 5, oh, that should be a plus 5 there, because it was minus minus, so that should be a plus 5 up here. So that's going to be, let me just check that. Something's gone wrong there. Sorry, that should be minus 15 over 4. And then I've got my plus my 5. So that should be just plus 5 over 4. Okay, that was different than what I had written down there. I think I made a wee mistake there earlier on. Okay, and then when we tidy it up, right, I made a real mess of that, so I'm just going to do this. Take a 2 outside a bracket, and then you've got positive ln 3, then it was minus ln 4 and minus ln 2, and then plus your 5 over 4, and then sorting out all your lns here. You've got on your top line is going to be ln, it's going to be 3, and the bottom line is going to be 4 times the 2, and then plus your 5 over 4. So that this can sort out to be 2 ln of 3 over 8, and then plus 5 over 4. And this is a bit I'd made a mistake on earlier on, so hopefully I've corrected that. Hopefully that is now right. So there we go. If it's not, apologies. Okay, couple of blank pages for good measure in this one. Then we had a, strange enough, AP question. It says, in round 1 of a game show, contestants get a prize of £100 for their first correct answer. With each subsequent correct answer, the prize money per question is increased by 50. Mandy won 3,250. How many questions did she answer? First of all, it's an AP, but why it's an AP? She gets £100 first of all. Next one, she would get 150. Next one, she would get 200, and so on. So clearly your A, your first term is 100, and your common difference is 50. We know that the sum of all her rounds added up, she got £3,250, but we don't know what the n is. So we'll write down the formula for S of n. It's n over 2 times 2a plus n minus 1d. Now let's fill out in what we know. We know what she won, so her sum of her n was 3,250. That's n over 2 times 2a is going to be 200 plus n minus 1d, so that's going to be 50 times n minus 1. Now multiply across by that 2, you'll have 6,500 is equal to, and then multiply in by the n, 200n, and then that's going to be plus 50n squared minus 50n. Sort that out, bring it all to one side, put it equal to 0, have 50n squared plus 150n minus 6,500. Divide through by 50 to make life a wee bit easier. N squared plus 3n minus 130. If you don't spot it, use your quadratic equation to factorize or to solve that, but hopefully you spot it. It's n plus 13, n minus 10. which means n is equal to minus 13 or n is equal to 10. So your answer is n is equal to 10. So 10 goes. Next question. Changes a wee bit in round 2 of the game. Round 2 of the game, what happens? The prize values are different but are awarded in the same way. So John answered 6 correct answers. So he's done this game 6 times and got 2,325. Martha answers 3 questions. So S3 is 825. Now let's just put that into the formula again. 2, 3, 2, 5 then. For this, what you've got to find, is your A and your D. So the initial prize money and the increase. So n over 2, so 6 over 2. We'll just write it as 6 over 2. And then 2A plus n minus 1 D. So 6 minus 1 is 5 times your D. So that's what you've got. We'll sort this one out. That means 6 over 3 is just, 6 over 2, is 3. So 2, 3, 2, 5 is equal to 3 times 2A plus 5D. So 2, 3, 2, 5 is equal to 6A plus 15D. And you can divide through by 3 to give you 7, 7, 5 is equal to 2A plus 5D. Dot, 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 we'll call that equation 1. You can guess where we're going from this one, I'm sure. A bit of simultaneous equations. This one, that means 825, and remember your sum of your n term, is n over 2, so 3 over 2 times 2a plus n minus 1, which is going to be 2d, and then that's 825, and if you multiply in 3 over 2 times 2a, you're going to have 3a, same for your d, you're going to have 3d, and you can make life a wee bit easier by dividing 3 by 3, 275 is equal to a plus d, dot, 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 equation 2. Okay, 2 equations, 2 unknowns. I'm going to multiply my equation 2 by 2, and that's going to give me 550 is equal to 2a plus 2d, and then I'm just going to subtract, so do equation 1 minus 2 times my equation 2, which would give me 225 is equal to 3d. D then equals 75. Therefore, your A is equal to 275 minus the 75. So your A works out to be £200. 200, sorry. So your answer, related back to the question, there were £200 for the first question, if you get it correct. And then the increase is £75. £75 was the increase every question, but if you write the increase, I'll know exactly what you mean. Now let's think about this. The first round it was £100, and then it was a £50 increase. Second round, and typically in the second round, questions get harder, so the prize money gets bigger. £200 to start off with, and then £75 increase. So it makes sense in the real world. Okay. It says, using the compound angle formula for this, where a plus b, given in your formula booklet, prove that this thing, cos of 2a is equal to 1 minus 2 sine squared. Cos of a plus b in your formula booklet is cos of a cos of b minus sine of a sine of b. I just say let b equal a. So that means it becomes cos of 2a is equal to cos squared of a minus sine squared of a. Now we know sine squared plus cos squared equals 1, which means cos squared a is equal to 1 minus sine squared a. So that means you can say, therefore, cos of 2a is equal to 1 minus sine squared of a minus sine squared of a, which is equal to 1 minus 2 sine squared of a as required. Lovely. And you know you've got your marks. Next question says, find the exact value of tan 2a, where a is a acute angle, sine is equal to this thing. So a is equal to sine to the minus 1, of 2 over root 7, which means, reverse that, sine a is equal to 2 over root 7. Now to do this, there's all sort of weird and wonderful ways of doing this, but the nicer way is just draw, no matter what it tells you, if it tells you it's an acute angle, obtuse, reflex, whatever, draw a wee right angle triangle, call that a, and then sine, remember, is opposite, so over hypotenuse. So the 2 goes here, that's where the opposite is. The root 7 goes there, that's where the hypotenuse is. Now, by Pythagoras then, this side is going to be the square root of root 7 squared minus 2 squared, which works out to be root of 3. Okay, so that means you can get what tan of A is from this triangle. Tan is equal to opposite over adjacent, so 2 over root 3. And from your double angles, from your formula booklet, it tells you what tan of A plus B is. Using that same technique from earlier on, you can then get tan of 2A is equal to 2 tan A over 1 minus tan squared of A, and then it is just firing this into your calculator. So that's 2 times 2 over root 3 over 1 minus 2 over root 3 squared. I have a lot more working out written down here after this, but there's absolutely no need for it. You fire that in your calculator, you get minus 4 root 3 for your full marks. Okay, auxiliary angles here. It says expression 2 cos 2x plus 5 sine 2x can be written in the form r cos 2x minus alpha. They give it to you, so just expand that thing. We're going to you've got to find the values of r and theta. So we look at your r cos 2x minus alpha. Do that out. It's going to be r cos of 2x cos of alpha plus r sine of 2x sine of alpha. I've squeezed that in there, apologies. So equate the coefficients. This 2 is equal to r cos alpha, and in blue this 5 is equal to r sine of alpha. So that's where you get this from. So r cos alpha is equal to 2. Likewise, r sine alpha is equal to 5. Your r is equal to 2 squared plus 5 squared and the square root of that. So r works out perfectly as root 29. Tan alpha is equal to the sine one divided by the cos one. And then your alpha works out to be 68.19859. Or alpha is equal to 68.2 to 3 sig figs. Now I wrote it the shorter way for the answer here, but I will probably use this. I will use this the longer way in the next part of the question, because it's need to be used in my working out. Okay, next part of the question says, hence find the solutions of this thing. So this left-hand side, we could write this as root of 29, perfect, times cos of 2x minus 68 point, can I just check that? 19859, 19859 is what I've written down. 19859 is equal to 3. Okay, so first thing you would do is you would say that means cos of 2x minus 68.19859 is equal to 3 over root 29. Do your basic angle, and I got 56.14549. And also that is on, so this range has to change because our angle bit is different. So you do the angle, write in the angle bit first. What was it? 2x minus 68.19859. So that's going to be less than, so do 2 times 180 and then take away the 68.19859, and I got, if I could read this, 291.80141, and over here that's just me minus 68.19859. So you do your cast diagram, C, A, S, and T. There's your 0. It's positive, so it's going to be in here and here. So that's going to be your 56.1 and so on, 56.1 dot dot dot. So my first angle is round to here. So my first angle, what was that? 2x minus 68.19859 is equal to 56.14549. And my next angle is going back the way, so it's just been minus the same, minus 56.14549. And then bring the 68 across, and you'll have 12.05311, or 124.34408. And divide through by your x, you'll have 6.03 degrees to 3 sig figs, sorry, and 62.2 degrees, and both those were the 3 sig figs. Okay, implicit differentiation, this next one. Curve is defined by this equation. First thing I would do here, you're defined dy by dx. I'd rewrite it as 3y squared plus 2x minus 3x y to the minus 1 is equal to 5. And what you're doing here is you're differentiating everything with respect to x. So to do the 3y squared, it's completely in terms of y. So what you do is you just differentiate with respect to y. You get 6y, and then just slap a dy by dx on the end. Okay, it's from the chain rule, but that's a really quick, easy way of doing it. Differentiate 2x with respect to x, you get 2. And then this is a product. So we'll do this down here. That's going to be minus of, and then we're differentiating the 3x first. You get 3. Leave the y to the minus 1 as it is. Then write down the 3x. That's just plus 3x. And differentiate y to the minus 1. You will get minus y to the minus 2 times your dy by dx. And then differentiate on the right hand side, then differentiate to 5, you'll get 0. So an absolute mess. Let's tidy it up a bit. That's 6y dy by dx plus 2, and that's going to be minus 3 over y. I'll write it like that. And then over here, that's going to be minus, that's going to be plus 3x over y squared dy by dx then is equal to 0. Group all the dy's together, dy by dx's together, sorry, you'll have 6y plus 3x over y squared. And then fire everything else across, you'll have 3 over y minus 2. And then you want to get your dy by dx on its own. So you're going to have 3 over y minus 2, all divided by, and this looks ugly, 6y plus 3x over y squared. So an absolute mess, a horrible looking function. So what you could do, and I would do this in the exam, I'd multiply 3 by y squared. So you have 4 terms, they all get multiplied by y squared. 3 over y multiplied by y squared would just be 3y. Minus 2 multiplied by y squared is minus 2y squared. Bottom line, 6y multiplied by y squared is 6y cubed. And 3x over y squared multiplied by y squared gives you 3x. And I think you would probably need that. I wouldn't be happy if somebody presented me with this as an answer, if I'm honest. So I would just multiply that out. How are we doing? Okay, next one. Oh, messed this up royally when I did this one. Made all sorts of mistakes. So hopefully, oh no, this is probably apologies. Wasn't this one at all. This is quite nice actually, a bit strange but quite nice. It says, consider the curve with the equation y is equal to 3x upon e to the 2x. Find the equation of the tangent. If you see tangent, word tangent, you know you're going to be doing dy by dx. So dy by dx first. Again, that's a function. You have 3x times e to the 2x. Differentiate the 3x. First of all, you get 3. Then write down the e to the 2x. Then you've got the 3x, differentiate e to the 2x, you'll get 2e to the 2x, and then that becomes 3e to the 2x plus 6x e to the 2x. So that is the same. I don't know if this is going to help me any, but I've just factorized out e to the 2x, giving me 1 plus 2x. Okay? Right, I need to find the equation of the tangent. That's my gradient function. I need to find the gradient of the equation of the tangent when x equals minus 2. So just say when x equals minus 2, first of all, your y equals 3 times minus 2, which is minus 6, e to the minus 4. So you've got a point, perfect point, an exact point, minus 2, minus 6e to the minus 4. Leave it as that. Don't change it. Okay, and also, just say when x equals minus 2, your dy by dx equals 3e to the minus 4, and then 1, then minus 4, upon 1 minus 4, so that's going to be minus 3 times 3, which is minus 9e to the minus 4. So your tangent, remember why we're doing all this, the equation of your tangent is y is equal to mx plus c. So you know that's y is equal to minus 9e to the minus 4 times your x plus your c. And then we want to sub in our point. So the point, you can just see it on the top of the screen there, just about. Sub in minus 2 minus 6e to the minus 4. So that means minus 6e to the minus 4, that was your y, is equal to minus 9e to the minus 4 times minus 2, which is plus 18e to the minus 4, and plus your c. Bring that across the other side, you will have minus 24e to the minus 4 is equal to c. And that means your y is equal to minus 9e to the minus 4 times x, then minus 24e to the minus 4. Look at the question, it tells you to get it in the form e to the a times that. So what I could just do is multiply through by e to the positive 4, which gives you e to the 4y is equal to minus 9x minus 24 just. And that is what we're looking for. Okay, next question says this curve has one turning point. Find the same question. Sorry, find the coordinates of this point. So first of all, we knew dy by dx was equal to 3e to the 2x, 1 plus 2x. To find the turning point, put 0 equal to that, 3e to the 2x, 1 plus 2x. So that means 3e to the 2x equals 0, and that's not actually possible. Your e to the x graph never actually touches the y-axis. The x-axis, sorry, so that's never going to be equal to 0. So 1 plus 2x equals 0. Wee bit of working out means x equals minus a half. Okay, so we'll need to find the corresponding y value. So say when x equals minus a half, your y is going to be equal to, so this is going back to your original y, wherever my original y is, e to the x, e to the 2x. So that's going to be, sorry, I've forgotten that already. It wasn't that at all. It was 3x e to the 2x. So it's going to be 3 times minus a half times e to the, and that will be minus 1. So that works out, your y value works out as minus 3, not pretty, minus 3 over 2 e to the minus 1. Okay, let's write down, let's change my dy by dx a wee bit. Just awkward to differentiate in that form. Well, some of you might prefer it, but I would just multiply it out. You're going to have e to the 2x plus 6x e to the 2x. And now we can differentiate this. So why we're differentiating this, we're to find the nature of the turning points. So that's going to be 6e to the 2x. This is a product again, so that's going to be just 6e to the 2x. And then differentiate the e to the 2x, you're going to have 2e to the 2x, so that's now going to become 12x e to the 2x. So overall what we've got is 12e to the 2x plus 12x e to the 2x. Now when you say put in your x value, which you knew of the turning point was minus a half, your d2y by dx squared works out to be 12 times 12 times e to the minus 1. And then that's going to be minus 6 e to the minus 1. So e to the minus 1 is positive. 12 times e to the minus 1 minus 6 times e to the minus 1 is going to be 6 e to the minus 1, which is going to be greater than 0. Therefore, what that tells you is your point, which is minus a half, and it was minus 3 over 2 e to the minus 1, is a minimum turning point. Now, I'm not too sure if they wanted that answer or this one, so just give it to 3 sig figs then, or minus 0.5 and 0.52 is a minimum turning point, and that's the 3 sig figs. Question 9 says the graphs of the function f of x equals a of x and g of x equals x plus 4 intersect at a point where x equals a. Show that the value of a lies between x equals 1 and 1 and 2. So first of all, I'm going to find a new function h of x, and I'm just gonna do it as being the f of x minus the g of x. So I'm going to write that out then, see what that is. That's going to be e to the x and then minus x and minus 4. And then if we put in 1, so h of 1 is e to the 1 minus 4, and that worked out to be minus 2.28 something or other. And h of 2, so putting in the 2, you got e of 2 minus 4, which worked out to be 1.39 something or other. So let's say the change in sign indicates a root of the equation. So a lies between 1 and 2. Next one is the Newton-Raphson method. The Newton-Raphson method is given to your in your formula booklet. It says starting with x0, so that's your first approximation, 1.5, use the Newton-Raphson method twice to find a better approximation for the value of a. So the Newton-Raphson says that the better approximation is your initial approximation minus f of xn over f dash of xn. So that's your first better approximation is your first approximation minus better approximation is your first approximation minus f of your first approximation over f dash of your first approximation. Now your f of x, I called it h a minute ago, but it's just going to be e to the x minus 4. You also have to differentiate that thing, and you'll just get e to the x again minus 1. And then your x1, your better approximation is 1.5 minus e to the 1.5 minus 1.5 minus 4, and that's over e to the 1.5 minus 1. And I worked that out and I got 1.792 something or other. My x2 then is 1.792, and you can use your answer button in your calculator, and then minus, and then the top line is e to the 1.792 minus 1.5 minus 4 all over e to the 1.792 minus 1, and I fired that in and I got my x2, and now to 3 sig figs, 1.75 to 3 sig figs. Question, whatever this is, question 9b. Question 9b says curve has parametric equations, and it says find an expression for dy by dx. Now we'll come to this in a wee minute. Dy by dx is dy by dt times dt by dx. So the first thing we need to do here is find dx by dt. So if you differentiate cosec squared, now the derivative of cosec is given in your formula booklet. So if you think about this, x is equal to cosec t all squared. So it's a function of a function. So differentiate with respect to the bracket, you'll have 2 times cosec t, now to the power 1, and differentiate cosec, it tells you in the formula booklet that gives you minus cosec t cot t. Okay, so tally that up. That is minus 2 cosec squared t cot t. And your y was equal to just, what was it equal to? Just cot t. And you're told that one in the formula booklet. If you differentiate that, dy by dx, dy by dt, I should say, is going to be minus cosec squared t. So you've got your, and very importantly, dx by dt equals this, and then your, sorry, I'll get rid of that, and then your dy by dt is equal to this. So the formula was dy by dx is equal to, or dy by dt, which we can just write down as minus cosec squared t, and dt by dx then is 1 over, and then it was minus 2 cosec squared t cot t. So then if you sort that out, first of all, I'll just use green here to do a bit of cancelling. The minuses go, first of all, they can go. Cosec squared will go with this cosec squared, and that just leaves you 1 over 2 cot t. And remember what cot t is. Cot is 1 over tan, so that's a half tan t. And that's what we're looking for. Okay, differential equation. A cylindrical water tank is leaking water. A student believes that the rate of change of the depth d of water in the tank is proportional to the square of the depth of the tank at time t. So, d, capital D by dt is proportional to the square of the depth. And then I would just write dd by dt is equal to minus k d squared. I'll just say here minus, as it is losing water. Okay, it's leaking, so it's losing water. Okay, and that's it. So that was your forming a differential equation. People think they have to do an awful lot more than that. That's the differential equation. You've still got d something by dt. That's a differential equation. That's all you've got to do with that. And it's only 2 marks, so you're not going to want to do too much more. What we then want to do is a bit of separating the variables. So first of all, read the question. It says the initial depth of the water in the tank was 3 meters, and after 4 minutes, the depth of water in the tank had reduced to 1.2 meters. By solving the differential equation, find the time it will take for the depth of water in the tank to drop to 0.5 meters. Okay, right. Let me write down my equation again. What have I just said? d by dt is equal to minus k d squared. Now, I'm going to bring that across, and I'm going to write that as 1 over d squared then, dt. Right, don't write this down as we second. 1 over d squared dt over dt is equal to minus k. Now, I know this isn't what's happening, but I think about it as being that dt multiplies across, and that's what I get. That's mathematical nonsense. Slap an integration sign in front of it, and then it makes sense. So that's really what you've got too. So write this in index form. That's what you've got. And then we can integrate that. I'm just going to do that here so that we can see it. Integrate this left-hand side, raise the power by 1 and divide by the new power. You will get minus d to the minus 1. Integrate the right-hand side, you'll get minus kt plus c. Okay, that is the same. You can change the sign of everything there. Any negatives, you haven't assigned. I can make that minus d to the power minus 1 positive, so make it I'll write it as 1 over d, and then that's positive kt. And I could have changed that to right minus c. There's absolutely no need. Just leave it as c. We haven't assigned a value to any of these constants yet at all, so we can do that. It makes life much easier. Right, we're told, it says the initial depth of water in a tank. So initially, when t is equal to 0, the depth is 3. So let's put that in. 1 over 3 is equal to 0 plus c. So that means just 1 over c is equal to c. So if you're a good mathematician, anytime you get a constant, you'll rewrite your equation. So 1 over d is equal to, and that is going to be kt plus 1/3. Okay, next bit of information it tells you is when t is equal to 4, the depth is 1.2. So we'll just write that in. When t is equal to 4, the depth is 1.2. Right, let me just write down what I had up above there. And 1 over d is equal to kt plus 1/3, and then we're just going to put in what we now know. So that means 1 divided by 1.2 is equal to, that's going to be 4k plus 1/3, and then 1 over 1.2 minus 1/3 is equal to 4k. That's a half is equal to 4k, and that means that 1/2 divided by 4 is equal to k, and so k is equal to 1/8. As I said, good mathematician, you'll rewrite your equation. So the equation now becomes 1 over d is equal to 1 over 8 times t, and then plus 1/3. Okay, right, you could work with this. I just didn't like to because I thought it was a mess. It says the next part, find the time for the water in the tank to drop to 0.5. You could just fire in D is equal to 0.5 here. That might be as easy. In fact, you know what? No, I won't. I'll do it. You could just fire that in at that stage, but I'm going to do it the same way as I've just done it. So what I did is I tidied up. I took a common denominator. So wrote that as 1 over D is equal to, and my common denominator over here is going to be 24. So that's going to be 3t plus 8. And then once you've got that, you could just multiply across by the 24. 24 over D is equal to 3t plus 8. And then I'm going to go on and define the time. I'll just keep going and rearrange this. You don't have to do this yet. You could put in the values if you want. That will work the same. So you've got that for your t, 3t, sorry. Then t is going to be 1/3 times 24 over D minus 8. Now, they wanted to find the time when the depth was 0.5. So put D equals 0.5. Then t will be 1/3 times 24 over 0.5 and then minus 8. 24 over 0.5 would be 48. Take away 8 would be 40. Then multiply by 1/3. That's going to be 40 over 3. That works out to be your t is 13 1/3 minutes, which is 13 minutes. Squeezing this on again, apologies. 13 minutes and 20 seconds. 13 minutes and 20 seconds. Okay, we're almost there. I think this is the last question. Nope. Oh, I have missed a bit, have I? I have indeed. Find the exact value of this thing. An awful lot easier than it looked. I thought we were going to have a wee bit of integrating sine squareds and cos squareds here, but we don't. If we multiply that out, sine squared plus cos squared squared would give you sine squared x plus 2 sine x cos x plus cos squared x dx. Now, sine squared plus cos squared equals just 1. And then this term in here, that is the same as sine 2x. That's the easiest way to do this. That's using your double angle formula. Okay, which you really should know if you're going into an A-level maths exam. And then integrate 1 with respect to x, you get x. Integrate the sine 2x, you will get minus 1 over x cos 2x. If you don't believe me, just differentiate that and see if you get that you should get this, and you do. And then that's between pi over 0 and pi over 2. So the first square bracket, put in your pi over 2. The second square bracket, put in your 0. So it's just me pi over 2. Sorry, it's not pi over 2 at all. It's pi over 6. Apologies, pi over 6. Change that there. Pi over 6 and pi over 6. That's now pi over 6 minus a half times, then pi over 6 times 2 is pi over 3. And over here, it's just going to be 0 minus a half of cos of 0. And then that becomes just pi over 6. Cos of pi over 3 is a half, times a half will be a quarter. So that's what we've got there. And then this one is just going to be minus a half. So that overall it becomes, making a meal of this here, but pi over 6 minus a quarter, and then plus a half, and then that becomes pi over 6 plus 1/4. And that is, they asked you for the exact value, so that's an exact value. Okay, last question, I think it is. Here we are. Yep. It says the graph of the functions, f of x is equal to x ln x. Very, very common exam question. You've got to integrate a ln x or some form of it. And g of x is equal to x plus 1, or shown in the figure below. Find the exact value of the shaded area. Now, I'm going to do this using the area of the curve. I'm going to do this by the following. I'm going to say that the shaded area is equal to the integral between our limits, which are 1 and 3. That's where the limits of the two things going are. And you can see the g of x is on top and the f of x is on the bottom. So I'm going to do g of x minus the f of x dx. Now, just to show you another way you could have done it. You could have worked out the area of this whole trapezium, which would be fairly easy. You would need to find the heights of the trapezium, so the parallel sides, and then just take away the area on the curve. So that, I don't know which one's quicker. I haven't done that out, but I would imagine that would work as well, but I just prefer this method. It doesn't work out overly nice here, to be honest, but we'll go with it. So tidy that up a wee bit. You've one integral from 1 to 3, that was x plus 1, and then my f of x was x ln x dx, dot, 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 call that equation 1. We'll be coming back to that. Okay, now the problem part of this is integrating x ln x. Now, as I said, really, you should know how to do this. You should know how to integrate x ln x. It's a very special integration by parts. So we're going to investigate this, integrating x ln x dx. So for this, typically when you're doing integration by parts, you pick the u, such it's an easy function, such that du by dx is a simpler function. So normally you would make your u be equal to x, but when you've got ln, you should learn off this one, this sort of method, your u has to be equal to your ln x. That means your du by dx is equal to 1 over x, and your dv by dx is equal to just the x, so the v is equal to the x squared over 2. So the integration by parts tells you that the integral of u dv by dx, integrated with respect to x, gives you uv minus the integral of v du by dx. So here, my I becomes then uv, so what's my u and my v? It's going to be x squared over 2 times my ln of x, and then minus, and then it's my integral of v du. So v du is going to be this thing multiplied by this. So if I can skip a step then now, we can see that. So x squared over 2 times 1 over x would just be x over 2. And that's being integrated. Okay, so we'll just go ahead and we'll integrate this. So that's going to be x squared over 2 ln x. That's already integrated, that bit. This thing, when you integrate it, you're going to get x squared over 4. And technically we'll get a c here as well, which will be done away with in a wee minute. Okay, right. That was our area up here. Now the area was the integral of this thing, then minus the integral of this. This bit we have just worked out what we get when we integrate it. So when the next line I'm going to write down is just, we're going to write this down again, but you're going to be integrating the yellow bit. So integrate the x, you'll get x squared over 2. Integrate the 1, you'll get x. So that's just where this comes from. So my area then, my next line is just going to be, remember, integrate the x, you'll get x squared over 2. Integrate the 1, you'll get x. Then minus, and I'll put it in a bracket, because remember it was minusing the blue bit, and I've just shown the blue bit up above there. So we'll put it in a bracket. It was x squared over 2 ln of x minus x squared over 4. And we don't need the c because we've got limits on this thing now. Let me just check again. 3 and 1, yep. And then fire in the thing. So tidy this up a wee bit before we get started. What's that going to be? That's going to be x squared over 2 minus x squared over 2. That's going to be x squared over 2 plus x squared, sorry, x squared over 2 minus x squared over 4. So that's going to be 3x squared over 4, that would be. And then plus you've got an x, and minus you've an x squared over 2 ln x term. And that's between 3 and 1. And then we'll have 2 brackets. So the first bracket is just going to be 27 over 4, because that's 3 times 3 times 3 all over 4, plus 3. And then, have I done that right? Apologies. Yep, that should be right. And then 3, and then minus, that's going to be 9 over 2 ln of 3. And the next bracket, sorry, the next bracket then is going to be, next bracket is going to be just 3 over 4 plus 1, then minus 1/2 ln of 1. Now ln of 1 is 0, so if we just sort that out, that is going to be, what, sorry, that is going to be, we'll do the 24 over 4. I'm just doing this minus this. 24 over 4, and then the 3 minus a 1 is 2, and then that's going to be just minus 9 over 2 ln 3. That is right. That's I've done this a slightly different way. I don't know what I did differently there, but I got the same answer. 24 over 4 is 6, plus 2 then is going to be 8, and then minus 9 over 2 ln 3, and I've done it a different way and got the same answer, so hopefully that is right. Okay, so that is that done. If you can see I've made any mistakes, as I quite often do, please let me know in the comments, and then I can put that in the comments, and then people can check. Okay, thank you very much.